Hello everyone and welcome to the Math Bender. I am Adnan Zaidi and today we'll discuss arithmetic series. Before starting off, I wanted to tell you that we already have done arithmetic progression, which is our first lecture on sequence and series. So let's start. Just a quick recap. We talked about if this is, as we know, is an AP or arithmetic progression because it has a common difference and so on. But if I write the same progression like this, 2 plus 5 plus 8 plus 11 plus and so on, never ending terms, now this same thing becomes a series because it is referring to the sum of these numbers and so on. There are many other numbers which I haven't written down. So it is an infinite series because it is not ending. But what type of series is it? So if you find out the difference between the first and the second term, it is 3, second and the third, or any two consecutive terms, you see that the difference is common, so hence it is an arithmetic series. So the basic difference between a progression and series is that series caters to the sum and progression caters to the number of separate terms. Any arithmetic series and the sum can be calculated using Sn equals to n over 2 times 2a plus n minus 1 times d, where d is the common difference. We already know n is number of terms, a is the first term. So let's see some of the questions. Now we have these series. First step, let's take any random. So this is 30 plus 27 plus 24 plus 21, and it says up to 40 terms. So basically I have to find out the sum until 40 terms. So S40 or Sn equals to n over 2, 2a plus n minus 1 times d. So I am supposed to find the sum of 40 terms, where a is going to be equals to the first term, which is 30, and the difference is 27 minus 30 is equals to negative 3, and I'm supposed to find the sum for 40 terms. So S40 is equals to 40 over 2 times 2 times a, which is 30, plus n is 40 minus 1 times negative 3. So S40 is equals to 20 times 60 plus 39 times negative 3. So I'll straight away use calculator for that. So it gives you negative 1140. So sum of 40 terms is going to be negative 1140. Let's look at another question here. 5 plus 1 plus negative 3 plus negative 7 plus until 14 terms. Now first thing, let's see if it is an arithmetic series. So if I take out the difference, it is 1 minus 5, which is negative 4, -4, and so on. So here A is the first term, 5, D is -4, and I'm supposed to find the sum of S14. We know that Sn is equals to n over 2, 2a plus n minus 1 times d, and S14, so replacing n with 14 over 2, 2 times 5 plus n minus 1, which is 14 minus 1 times d, which is -4. S14 is 7, 10 plus 13 times -4, and you can use calculator to find out the sum of the first 14 terms. Let's look at some other questions here. Now it says that how many terms will give you the sum this much. Now, if you look at the first one, the series is 5 plus 8 plus 11 plus 14 plus 670. Now the first term, a is equals to 5, and the difference is 3. Now I have sum already, but I don't know how many terms does that take to reach that sum. So I write Sn is equals to 670. You could see that I don't know n, and this is what I need to find out. But I do know that there is a sum of 670. So now Sn is n over 2 times 2a plus n minus 1 times d, and it gives you 670. Replacing Sn with 670, n over 2 remains 2 times 5 plus n minus 1 times d is 3. Now, as you could see, that 2 here is dividing the whole, so I'll multiply it over there. So 670 times 2 gives you 1340 is equals to n times 10 plus 3n minus 3. 1340 is equals to n times 10 minus 3 is 7 plus 3n, and as I can see that it is turning out to be 3n squared plus 7n is equals to 1340, and a quadratic equation in place. Bringing this over there equals to 0. Now let's solve it. I'm using calculator's help. You may use factorization to solve that. So 3, 7, -1, 3, 4, 0. So gives you n is equals to 20 and n is equals to -63 over 7. So n is equals to 20 and n is equals to -63 over 7. Note that this is not practically possible. The number of terms cannot be negative. Neither can be fractional. It has to be, this is the only answer that will be in the accepted state. You may try solving this, pause the video, and I will solve in the meanwhile. So 34 plus 30 plus 26 plus 22, 112. So here Sn is equals to 112, A is equals to 34, the first term, and the difference is equals to 4, -4. Now Sn is equals to n over 2 times 2a plus n minus 1 times d, and 112 is equals to n over 2 times 2 into 34 plus n minus 1 times negative 4. It's a decreasing sequence anyway. Now 112 times 2 is equals to n times 2 times 34 is 68 minus 4n plus 4. And 112 times 2 gives you 224 is equals to 60. N times 68 and 4 makes it 72 minus 4n. Minus 4n squared plus 72n is equals to 224. And sending all the others on one side, and now solving the quadratic equation, this gives you 4 minus 72 and 224. So n is equals to 14 and n is equals to 4. Since both of them make sense and the sum has to reach 112, both of them will be acceptable. I'll explain the logic here in this question, although it is a very good question, because if you add these 1, 2, 3 and 4 terms, you will see that, let's add them first. 34 plus 30 plus 26 plus 22 gives you 112, and it is right. But as you could see that the sequence is decreasing and eventually will reach negative until the 14th term. So those addition and subtraction of all the positives and negative terms will end up getting 112 again. So there will be 2 times it is. So both the answers are correct unless there is a specified condition that you will have to select. Let's move on to question like past paper questions. You have to find out the sum of the first 50 even numbers. So which means 2 plus 4 plus 6 plus 8 plus and so on until n is equal to 50. So I need to find out the sum of 50 terms. This is what I don't know. The first term is 2 and the difference here is as well 2. We know that Sn is equals to n over 2 times 2a plus n minus 1 into d. And S50 is 50 over 2, 2 times 2 plus 50 minus 1 times d. So S50 is 25 times 4 plus 49 into 2. So 2550. Let's see another question. Find the least number of terms. By the way, if this question had been here, then we would have taken this one. But these are the least number of terms that would reach the sum of 112. But the question here is a little bit different. Find the least number of terms for the sum of 7 plus 12 plus 17 plus and so on to exceed 1000. So the sum has to exceed 1000. And we don't know how many terms will that take to reach or exceed 1000. So first check whether it is an arithmetic progression, although we have kept this question under the topic, so it's assumed, but you can check it first. This is 5. The difference here is as well 5, so it is an arithmetic. So now a is equals to 7. The difference is as well 5. And I need to find out the sum that is greater than 1000. Now I can write Sn is equals to n over 2 times 2a plus n minus 1 times d, and Sn has to be greater than 1000. So if I write that down, instead of this I write n over 2, 2a is 7 plus n minus 1 times difference is 5 has to be greater than 1000. Now this is my sum, and this is, it has to be the condition that is greater than 1000. Now I can write this as n times 14 plus 5n minus 5 after multiplying with them, greater than, sending this 2 and multiplying on the other side makes it 2000. It is turning out to be a quadratic inequality. So n times 14 minus 5 gives you 9 plus 5n, and 5n squared plus 9n minus 2000 is greater than 0, bringing everything here. Now in order to solve a quadratic inequality, all you need to do, since this is n squared is positive, it is going to be a smiley face. All you need to find is the root. So if I draw this roughly, one of the root is, so 19.1 and negative 20.9. So since it is greater, this is the region. So n has to be either greater than 19.1. So at 19.1 it will reach a point where it is 1000, but it has to exceed, so n will be equals to 20 first thing, and cannot be in points, but if it is coming out to be, it means that in this series there won't a number come which is equals to exactly 1000. Either it will be less. So if you try to test it, if n is equals to 19, you will observe that the sum of this series is going to be less than 1000. So S19, let's find it out. 19 over 2, 2 times 7 plus 19 minus 1 is 18, 18 times d, which is 5. I'm just testing it. So if you take this out as 19 over 2 times 14 plus 18 times 5, so it gives you 988. So sum of 19 terms is 988. And let's take out the sum of 20 terms. You'll see that it will exceed 1000. So 20 over 2. So 2 times 7 plus 20 minus 1, which is 19 times 5. So as you could see, the 20 terms is exceeding 1000 and reaching a 1090. So that is how you approach it. So this is it for today's and series session. In my next session, I will solve mixed questions related to sequence and series of arithmetic progression. Until then, take care. Bye.